To you all. So my name is Atwendere Enoch. As you're seeing on the screen, so that is my registration number, and I'm all here just about computation math, and this is the coursework which is all about matrix as you're seeing. So first of all, matrix is a rectangular array of numbers, symbols, or expressions with elements or entries arranged in rows and columns, which is used to represent a mathematical object. So as you're seeing there, we are having the order of matrices. Firstly, we're having a 2 by 2 order, as you're seeing. So matrices is organized in rows and columns, as you're seeing. So the order we are having the order of matrices, which is a row by column, as you're seeing. So here we are seeing that the order of matrix can be denoted by that A in those brackets, and that I represents rows, then the J represents columns. So that MN represents the order of the matrix. So that is M by N. As you're seeing above, we are having a 2 by 2 matrix. So when we continue here, we are seeing types of matrices, and in types of matrices we are having row matrix, which means that matrix has only one row, and here we are having also another type as column matrix, of which the matrix has only one column. And then we are having also a square matrix, of which a matrix has all the rows and columns the same, or you can say a square matrix is a matrix with the same number of rows and columns as you're seeing. So we are having also null matrix as a type of matrices. This null matrix is a matrix without row or column, so that is, in short terms, that is a zero matrix. Then when we continue, we are also having diagonal matrix. So that is a matrix with the same number of elements in a diagonal form. We are also having identical matrices. So that is the type of matrix with the identical entries. That is to say, ones in the major diagonal and the zeros in the minor diagonal, as indicated below. So those are the types of matrices. So when we proceed, we are going to see the operations used in matrices, as you're seeing. So here we are having addition. When using this operation of matrix, entries in the first matrix must be corresponding with entries in the second matrix. We are also having subtraction as an operation in matrix. So subtraction in matrix is also like that of addition, because all the entries in the first matrix must be corresponding with the entries in the second matrix. So we are having also multiplication as an operation used in matrices. So when using this operation, we multiply a row by column. That is multiplication. How it is used, we multiply a row by column. So we are also having, we can also say that two matrices are equal only when the corresponding elements are equal. So that is to say, when you're having like one appearing in the first row and the first column, and then in the first matrix, then also another one appearing in the first column and the first row in the other matrix. So we regard that one to be an equal matrix. So there we continue. So we are having other terms in matrix, as you're seeing. For example, you're given such a number that K is equal to that matrix. So then you try to determine the determinant of that matrix. So the determinant of matrix K is determined as you're seeing. It is major diagonal minus minor diagonal. And the major diagonal, that is to say AD as you're seeing, minus the CD as you're seeing. We also having the adjoint as you're seeing. So adjoint, this one, when you're dealing with adjoint, as you're seeing in our matrix, we are having K equating to A, B, C, D. So when it comes to that, in adjoint, the major diagonal, the entries change the positions. The one which has been in the upper position turns to the downer position, as you're seeing. That A have replaced B and B have replaced A. And then also the signs have to change. For example, as you're seeing, in the matrix we had C as positive and B as positive. But this one we only change the signs in what? In the major diagonal, sorry, in the minor diagonal. Yeah, in the minor diagonal, that's where we change the signs. And then here we are also having the inverse. The inverse now. In the inverse, you're having K, the inverse of K. So here, on determining the inverse of K, K is equal to 1 over the determinant. So we're having our coefficient as 1 near that matrix. We're having our coefficient as 1. So that one we make it a fraction. We make it to be a fraction of which a 1 is out of the determinant. So into the adjoint. So we are going to get 1 over determinant into the adjoint as you're seeing. So we have transferred the adjoint here as you're seeing. There we continue. There we are having, we are now going to look on how we can get the determinant of a 3 by 3 matrix, of which the other one, the previous one we were tackling, that one means that we have been tackling over a 2 by 2 matrix, but here we are on a 3 by 3 matrix. How do we come to this? We are given such a number that matrix A equals that, as you're seeing. Now, how are we going to get the determinant? The determinant of that matrix. So there we come. We are getting the determinant of A, of which A, its values are there as you're seeing. So here we are having our A. We are having A, B, C, D, E, F, G, H, and J. So as we are determining, here down you're seeing that we are having the determinant of A equating to that small a, or that value that has been in the entries of that matrix. So here, to consider this A, you have to first cover the column where A belongs, at the same time the row where it belongs. So what remains is what you consider as the entries of that A. So you get the determinant of that A or using the other method of a 2 by 2 matrix, as we are defining the determinant. So here we are going to say, that is to say, major diagonal minus minor diagonal, and of which here the major diagonal is EJ and the minor diagonal is HF. Now there we go. So you subtract, you bring the entries of A you subtract the entries of B, again you add the entries of C. So that is the determinant, how we get the determinant of a 3 by 3 matrix. There we go. We're having our example here. As we have been in the operations used in matrices, we had that we are using addition, we are using subtraction, and we are using also multiplication. So here we are going to use two operations at a go. So you're given such a number that 3a plus c4x is equal to 7b. How do we tackle this? Yes? So you first get your entries of the what? Of the known ones, and of which we expect the known ones to be 3a, that is 3a plus 4x equating to 7b. So 3a, these are the entries of that matrix. As you're seeing, the ones of 4x, we don't know their entries. There we come to the 7b, and of which we are having its entries clear, as you're seeing. Then there we come down. As you know, in mathematics, real mathematics, we use in real mathematics we used to say that when you're having one unknown and one you're having it, and what the product of that, you have the product of where either you have added or subtracted, you have that product with you. So it's the same story here. We are having our unknowns being added with the known ones in the same side, and then equating to the product well given, as you're seeing. So here we are having the first matrix as the known ones, and the second matrix where we add the unknown ones. So here we're going to collect like terms. We take the known ones in one side and the unknown ones remain the other side. So here you subtract, since it has been addition this side, which means the other side you are going to subtract and get the answer. So here we have subtracted. I think you have all got the values as the ones I have got. Right. So let's continue. So here we are having multiplication. How do we multiply? So here we are given here our values. Yes, and the values we are multiplying now, a 2 by 3 matrix being multiplied by a 2, a 2 by 3 matrix being multiplied by a 3 by 2 matrix. So here, when we come here, how do we multiply matrices here? So here we multiply, the law of matrices tells us to multiply a row by a column. So here we are going to multiply a row. How does the row move? The rows move from left to right, as you're seeing. So the row, as I can read for you and you see what I'm talking of, the first row we are having 2, 3, and 4. And the second row we are having a 3, 5, and a 2. So when we are talking of columns flow from up to down, as you're seeing. As I can say, 2, 3, and then 3, 5, then 4, 2. Those are columns. So we regard that one to be as in a 2 by 3 matrix. Then the next one, a 3, 2, 4, 1, 6, and 4. So those are rows. Then when I talk of columns, as I've said, they flow from up to down. So that is to say 3, 4, and 6. And then another column, we are having 2, 1, and 4. So as we are multiplying here, what you have to consider, multiplying a row by a column as a must. We are multiplying a row by a column as a must. So here what are we going to do? We are going to say a 2 times 3 as you're seeing, plus a 3 times 4 as you're seeing, then plus a 4 times a 6 as you're seeing. So that is the first row. Then the second row, we are having a 3 times 3 plus 5 times 4 in the other matrix is a 2 by 6 in the other matrix. Those are two rows. Then as I'm to complete, you can see a 2 times 2 plus 3 times 1 plus 4 times 4. Then also a 3 times 2 plus 5 times 1 plus 2 times 4. So that is addition in matrix. And I think you can now get the answer. When you multiply and add the values correctly, I am sure you're going to get such an answer. And of which when you get that, we regard you to be on the right track. Here we come. We are given another number here now. We are going to test the other terms of which I told you about, the determinant, the adjoint, and the inverse. Alright? So we are given n. We are given matrix n equals and those are the entries 2, 4, 1, and 3. So find the determinant. As I had told you earlier, that the determinant is got by major diagonal minus the minor diagonal, and of which the major diagonal here we are having 2 and 3. So we multiply them, alright? We are going to multiply them, then we subtract them. Subtract the major and the minor. So we are going to get our major diagonal as 2 times 3 minus the minor diagonal as 1 times 4. So here we are going to get our answer as you're seeing 6 minus 4, then the answer will be 2. We are having also the adjoint, as I had told you. I'm sure you all know how to get the adjoint from my explanation above. So we are having a 3. We are having our 3 from the explanation I gave you above. I told you that in adjoint, here we change the positions of the minor diagonal. The one that has been in the upper corner comes in the lower corner. But this is only done in a 2 by 2 matrix, not a 3 by 3. This is only done in a 2 by 2 matrices. Now, there we go. We have now interchanged the positions of the major diagonal. Now, what happens to the minor diagonal, as I can ask? Minor diagonal. Here we are going to change the signs. We are going to change the signs of the minor diagonal. So here, in the question that we have been given, we are seeing that we had positive 1 and a positive 4. So here we are going to change the signs, so of which they are going all to become negative, since they have all been positives. They are now going to become negatives. Now when we continue, we're also going to see the inverse of n. So that's how we write the sign of inverse, as you can see, right? That n, which is the name of the matrix, then the inverse sign is, as you can see, negative and the power 1. Yes? Alright. So this equals to 1 over the determinant into the adjoint. That's how we get the inverse. There we come. After getting that formula, you come here and you say 1 over the determinant, of which the determinant we got our 2. Then you open the bracket, you shift the other adjoint into these brackets. Then here we come and substitute in your whatever. You substitute in, you get that fraction times multiply it by everything inside that bracket, but separately. Like for example, a half, or that 1/2, which was the determinant, times 3. You again multiply it by -4, again multiply it by -1, and the +2 final. So there we come also, and we get the value. I think you can now see the answer. We come now here. Example 2. If now here we are going to see you're given something like this, that if matrix A is equal to this, and B is equal to this, and R is AB, what comes into your mind? I'm sure the ones who have been following, you can know what comes next after that one. So after seeing something like this, I'm sure what comes into your mind is multiplication of matrices. Multiplication. So I think any number, when you get like a B, a C, a D, automatically that is the multiplication. Alright? Yeah. Now there we come. As I had told you that in multiplication, we multiply a row by column. So if you're there, you can also practice this. That is to say, first row times times one of the columns, and you follow the steps as I had told you. So here, the first question here to be asked, determine the order of the matrix R. So what comes into your minds when they talk of order? Remember, I told you above that the order, we are having an order of a column, a row by column, right? So here we are, when you multiply the results, or the outcomes of our multiplication is what gives you the what is what gives you the order of the matrix. But before still you can find it and get it, we are seeing that the first matrix of A has 3 by 2, then times 3 times 2 by 3. So there you can also find it by yourself, of which you cancel. You get 3 by 2 by 3 by 2. Then you cancel the next ones, right? You cancel the next ones, not the first ones. Yeah, there we continue. So this is what I've been talking of, finding matrix R. Then matrix R, I think you can see matrix R is equal to what? Multiplying the above A and B. So when you reach there, you multiply. Be careful, because these things you don't need to cram. You have to understand the way they are flowing. I'm sure I have been following and you understand what I'm talking of. So in multiplication, that's how we do matrix. Multiply a row by column. So I think you have got it. Here we come. Matrix but in word problems, right? So I think you all know word problems because you all studied mathematics as well. So here we are having our question here, that Tom, Bob, we are having Tom, Bob, and Ben went to a supermarket for a shopping. Tom bought 3 pens, 5 books, and 4 rulers. Tom bought 3 pens, 5 pens, and 4 rulers. Bob bought 4 pens and 3 books and 2 rulers. Then Ben bought 6 pens, 3 rulers. Then the cost of a pen is shillings 500, a book shillings 800, and a ruler is 1,500. Now the first question comes in. Write down a 3 by 3 matrix for the items bought by the boys. Right? So you can note this question, yes? Write down a 3 by 3 matrix for the items bought by the boys. Then the next one says a 3 by 1, write down a 3 by 1 cost matrix for each item. I think you can get, yes? I think you can all get what I'm saying. Then use a matrix multiplication to find the amount of money spent by each of the boys. Yeah, we are coming to the solution. So that is the summary. That is the summary I've summarized, and I've drawn that short table for you to clearly observe what was taking place. So the first question required us to write a 3 by 3 matrix of the items that was bought by the boys, and that is the 3 by 3 matrix. So when you have that box as you're seeing it, which contains the items and the names of the boys, I'm sure you can make that matrix as easy as possible. Now here we come. That is the matrix I'm talking of. You're having a 3 by 3 matrix as you have been asked in the question above. Then that 3 by 3 matrix, as you're seeing it, they also asked us to get a 3 by 1 of the cost of each item, right? So that is the cost. So as we are seeing that, we consider row by column. So I think you can see that the rows are 3, but the column is only 1, right? Now here we come. The next question was saying that using the matrix, using multiplication, find the amount of money each boy spent on buying the items. Yes, there we come in and multiply using the other method of multiplication, right? We multiply a row by column. I think you all noted that. There we come, multiply a row by column as you're seeing. So this first row goes with the first column, and the second one, as you can see. Therefore, that is the total amount of money each boy spent on the items that were bought. We come now